new material of the semester. It's really just pulling a lot of stuff together that we've talked about in the past. So we're going to be fitting curves to data. We have fit lines to data, and we have fit polynomials to data. Today we're going to talk about fitting exponentials and logistics to data as well, and logarithmic functions. So the general process for performing regression on your calculator is here. So this is just a reminder. We've done this many times. Once you're in the calc menu, and there are several kinds of regression you can choose. So you can choose linear, quadratic, cubic, quartic. You can choose exponential, logarithmic, and logistic. There are more, but those are the kinds of functions we've studied this semester. And if you don't have a graphing calculator with you, I'll go grab some after we go through this. So this first part is just to remind you of the steps for how to do regression. And then the second part is some words to live by when you're modeling. When you're looking at real life data, the more data you have, the better. Right? So if you only have a few data points, modeling with just a few data points is often not very reliable. If there's a theory-based reason to use a certain kind of function, for quadratics for projectile motion, for example, if Newton discovered that projectile motion is governed by a quadratic function, use a quadratic function when you're doing your modeling, right? 3 is a simple model that fits the data reasonably well is often preferable to a complex model that fits only slightly better. Right? So we like simplicity. And generally, if you use a model to find values between the known values, that's more accurate and more trusted than using them to extrapolate, which is to find values outside the data, like way far out in the future or something. And then to decide on what type of function to use. Sometimes it's not clear from the scatter plot what sort of function might best fit the model. So some suggestions would be to just try some different types, do 2 or 3 different regressions, and look at the R-squared value. So we'll give you an R-squared value, and the closer to 1 it is, the better the fit. But again, more complex models will tend to have higher R-squared values, but choose the simplest model that fits reasonably well. All right, so these are just some pictures of what your scatter plots might look like and what type of function you might choose. Right, so if they fall reasonably in a line, you might use linear function. 1 turning point, you might use a quadratic. 2 turning points, you might choose a cubic. 3 turning points, go with a quartic. And then exponential, we could have growth or decay. But look at this exponential growth function. A quadratic might also model that well, right? So there is no absolutely correct answer of what the best model is. It's just a model. It's just something that has the same behavior as your data. And then logarithmic, that's growth, but it's like slower. And logistic is when you have that leveling off kind of behavior. So we're just going to work through this activity today. You have 5 data sets. 2 of them have some context. And you're just going to fit some data to it. Write down the equation of the best model you can come up with. For 4 and 5, there's also some questions to answer rather than just writing down your model. And there are some answers on the next page, but it says here, other functions may also model the data well. So these are just some functions that I found that worked well. You might find a different function that's also a good model.